We are going to do a quick lesson on permutation and combinations today. We're going to talk about what each of those is, and then we're going to do one example for each kind of permutation and each kind of combination. So before we get too far into it, let's talk about some different terminology. If I have n number of options to choose from, and I'm choosing a certain number of those, we represent those as n and r. So if I have 10 pizza toppings to choose from and I have to pick 3, my n value would be 10 and my r value would be 3. So n choose r is a lot of times the way you'll see that written or in notation kind of like this. But n is your total number of options, r is how many of those you're choosing from. And then we're going to introduce a new term, a factorial, that exclamation point. We're not just super excited about math. A factorial is a mathematical representation for a number multiplied by every integer that comes prior to it. So 4 factorial is 4 times 3 times 2 times 1. 5 factorial would be 5 times 4 times 3 times 2 times 1, and so on. So you can find a factorial for any number. They can get really large as you get into larger factorials, but you don't have to do this by hand. I'm going to show you in the calculator where to find the factorial button. So, permutations, combinations. Let's talk about the difference between the two, because what we're talking about is how many different outcomes are possible. A permutation is when the order matters. So for example, if I'm setting a password or if I'm assigning roles to somebody in a job setting, the order matters. And I can have repetition or no repetition. If I'm able to repeat, for example, setting a 3-digit password, I can use the number 3 more than once. If I'm allowed to use repetition, this is my formula, n to the r power. So remember, n is my total number of possibilities to choose from, r is how many of them I'm choosing. So if I'm going to set a 3-digit password, n is how many numbers I have to pick from. Well, there's 1 through 9 and 0. So there's 10 numbers I'm choosing from, and I'm picking 3. So n is 10, r is 3. So my total number of password combinations or possibilities is 10 to the third, which is 1,000. So just for a 3-digit password using 0 through 9, there's 1,000 different password options that can be created. Okay, now what about when there's no repetition allowed, but the order still matters? I have another formula. This is where my factorial comes in. N factorial over n minus r factorial. So let's look at this example. What order could 16 pool balls be in? And then part of this is missing if I pick 3 balls. So I've got the 16 pool balls in a basket and I'm picking 3 of them at random. What order can they be in? Well, once I pick ball 2, I'm not going to pick it again because I'm not putting it back in the basket. So this is why there's no repetition allowed. So let's figure out what n and r, our values are for this scenario. I'm picking from 16 pool balls. So n is going to be 16. And I'm picking 3 of them, so r is 3. So I'm going to put those into my formula, 16 factorial over 16 minus 3 factorial. So that's going to be 16 factorial over 16 minus 3 is 13. So 16 factorial over 13 factorial. This is where I get my calculator now. I am going to put 16 factorial, which you get the factorial button by hitting math, going over to the probability menu, and then down to option 4. There's your factorial button. I'm going to do the same thing again, and then you need to put the number you're taking the factorial of before you bring in the exclamation point. And there are 3,360 different possible orders. Okay, so those are permutation. The order matters. Combination is when the order doesn't matter. So for example, listing the items that are in your lunch. If I say chips then sandwich, that's the same thing as saying sandwich then chips. So the order doesn't matter. And again, I can have repetition or no repetition. So in this first example, there are 5 ice cream flavors to choose from. How many 3-scoop combinations are possible? Now, if I'm picking 3 scoops, I could say I want 2 scoops of chocolate and 1 scoop of something else. I can repeat out of those 5 flavors. So this is my formula, and I just need to figure out what N and R are in this scenario. So I'm picking from 5 ice cream flavors, and I have 3 scoops. So that's going to be 3 plus 5 minus 1 factorial over 3 factorial times 5 minus 1 factorial. So simple math inside those parentheses. 5 plus 3 minus 1 is 7. The 3 factorial does not change, but 5 minus 1 is 4. So in my calculator, I'm going to do 7 factorial on top, and then in the bottom I have 3 factorial times 4 factorial. And my answer is 35 possible orders for this ice cream scenario. Okay, the last one we're going to look at is combination without repetition. And so in this first one, 10 students are running for 3 available student council positions. How many different election outcomes are possible? Well, this is my formula. There's no repetition because I'm not going to pick the same person to do more than one job. So N is going to be 10, and R is 3 because 10 students, 3 officer positions. Putting those into my formula, I'm going to put in my calculator 10 factorial divided by 3 factorial times 7 factorial. So once more, 10 factorial divided by 3 factorial times 7 factorial. And I have 120 different possibilities. So your first step is determining whether it's a permutation or a combination. This depends on whether or not it is the order matters, and then repetition or not determines which formula you use from there. So again, you're determining this based on this, the situation. It's just going to vary from situation to situation in the context. And then one more thing I do want to show you is that while you might not have one of these TI calculators at home, the calculator that's built into Delta Math can calculate a factorial for you. All you have to do is type in the exclamation point. So 3 exclamation point will give you 3 factorial. And let me expand this so you can see. So 3 factorial is indeed 6. You could also do 6 factorial and so on. So just because you don't have one of these fancy calculators at home, you can indeed use this in Delta Math, and you could even Google a factorial calculator if you wanted to. But the one that will be available to you in class on a test is the 84, so you do need to know those buttons as well. And that is it. That wraps up our lesson on permutations and combinations.